Hey guys, today we are going to build on our previous lesson where we talked about if we know lines are parallel, then we know something about their angle pair relationship. Today we're dealing with the converse of all of those statements. So our first one, our corresponding angles converse, we knew that if two lines were parallel, then the two angles, the two corresponding angles were congruent. Today we're saying if we know the two corresponding angles are congruent, then we know the lines are parallel. So remember, all converse means is to switch the hypothesis and conclusion. So we just switched their places. Alternate interior angles converse says the same thing. If we have two lines cut by a transversal so the alternate interior angles are congruent, then we know the two lines are parallel. Again, alternate exterior angles, same thing. If we know that our alternate exterior angles are congruent to each other, then we know the lines are parallel. And finally, our consecutive interior angles converse. Remember, these are not congruent to each other, but if we know that our consecutive interior angles are supplementary, if they add up to 180 degrees, then we still know that the lines are parallel. Okay, so how can we use this information? It says, is it possible to prove that lines P and Q are parallel? If so, state the postulate or theorem that you would use. So if we look at example 1, we have lines P and Q, and we have two angle measures. Well, what I notice is that those angle measures appear to be consecutive interior. They're both on the inside, and they're on the same side of the transversal. And so if I think back, consecutive interior should be supplementary. So we need to do 58 plus 122. So is 58 plus 122 180 degrees? And it is. So we can say that yes, it is possible to prove that. And our method then would be consecutive interior angles converse. Looking at example 2, it looks a little bit weird with that triangle in there, but I see lines P and Q that we want to know if they're parallel. And if I remember my angle addition postulate, then I know that 60 and 25 I can add together and just say that this whole angle here would just be 85 degrees. So that looks a lot nicer then, because if that's 85 degrees and that other angle over here is 85 degrees, those are alternate interior. They're on opposite sides of the alternate, and they're both on the inside. So I can say, once again, yes, by our alternate interior converse theorem. So these problems probably look pretty similar to what we saw in our notes from previous days, but this time it says find the value of x that would make A parallel to B or M parallel to N. So we want to use the information that we have to make sure that those lines are parallel. So this angle and this angle are in corresponding locations. They're corresponding angles. And I know that they should be congruent to each other if those lines are parallel. So I'm going to set it up just like I did yesterday. So 5x minus 7 and 98 would be set equal to each other. I'm going to add 7 to both sides. So 5x equals 105. divide by 5 on both sides. So x would equal 21. And that's all it asks for, so we can box that in, and we're finished with that. Then if I look at example 4, it looks to me like 4x and 6x minus 44 on opposite sides of the transversal, and they're both on the inside. So those are alternate interior angles. And again, alternate interior angles should be congruent to each other if those lines are parallel. So 4x equals 6x minus 44 is how we would set that up. So I'm going to move 6x over so that I leave something on the left side, and I have negative 2x equals negative 44. I'm going to divide by negative 2 on both sides. So x equals 22. Again, only asking for x, so we're done right there. All right, one last theorem for you. It says the transitive property of parallel lines. So think back to your transitive property that says if A equals B and B equals C, then A equals C. This property works very much the same. It says if two lines are parallel to the same line, then they are parallel to each other. So this shows you if we know that line P is parallel to line Q, and we also know that line Q is parallel to line R, then we know that we can go from beginning to end, that line P would also be parallel to line R. Okay, so notes were pretty short today. I would like for you to go over those theorems, those converse theorems. Think about what it means when we do converse. You need to know the difference between those. If you have any questions or want to go over any extra practice, please come in and see me. I will see you all in class.